students. Today we will be discussing the new topic thermochemistry. That is, we are starting unit 5. Unit 5 deals with thermochemistry. Unit 4, what we have studied, thermophysics we have studied. That is, whenever fluids are heated or cooled, because it's a very common practice to heat or cool the fluids in chemical industries. So heat changes. Either we have to supply heat, some quantity of heat, or we have to remove some quantity of heat. That is represented by Q, and we have done problems how to calculate Q when there is no chemical reaction. But now in this topic, thermochemistry, that is unit 5, we deal with energy changes when a reaction is taking place. Okay, energy changes when a chemical reaction is taking place. So here, thermochemistry, unit 5. Thermochemistry deals with the changes of energy in chemical reactions whenever a chemical reaction is taking place. So how to calculate the change in the energy, that topic is given by thermochemistry. So in this topic, first we need to understand some terms. One is, the very first term we need to understand is heat of reaction, and then standard heat of reaction. Then afterwards in next lectures, heat of formation and heat of combustion, Hezla. These are the topics we need to discuss. We need to understand these terms first before solving the actual problems where we calculate the energy changes during the reaction. So heat of reaction, delta HR. The heat of reaction is the energy that is released or absorbed when chemicals are transformed in a chemical reaction. So whenever a chemical reaction is taking place, some quantity of heat energy either will be absorbed or will be evolved. So that change, nothing but, in other words, the change in the total enthalpy of the products and the total enthalpy of the reactants. Okay, the change in enthalpy is nothing but heat content. So what is the total enthalpy of the products? What is the total enthalpy of the reactants? What is the difference? That difference only is nothing but the quantity of heat that is evolved or absorbed during the reaction. That is called heat of reaction, and it is represented by delta HR. Okay, the delta HR naught is different. Please make out the difference between these two. This is here, naught is not there, just delta HR. Here delta HR naught. Okay, so delta H, is it H stands for enthalpy, delta stands for change in enthalpy of the reaction. Change in enthalpy of the reaction is nothing but heat of reaction. So this is delta H. Simply sometimes we say it as delta H or delta HR. Now when delta HR is positive, that is endothermic reaction. That means for endothermic reactions we need to supply some amount of energy. Okay, for the transformation of reactants into the products, we need to supply some quantity of energy. So that is positive for endothermic. And for exothermic reactions, some quantity of energy will be released. So delta H will be negative for exothermic reactions. Next term is standard heat of reaction, delta HR naught. When we are using this term standard, this delta HR becomes delta HR naught or delta H25. This is also same, delta HR only, but what is the difference is all the reactants are at 25 degrees centigrade and all the products also at 25. The products formed are also at 25. Then what is the difference between the enthalpy of reactants and products. That is called standard, and pressure is 1 atmosphere. The standard heat of reaction is defined as the change in enthalpy resulting from the procedure of the reaction under a pressure of 1 atmosphere, starting and when ending with all materials at constant temperature of 25 degrees centigrade. That means in simple words, what we can say, when a reaction is taking place at a 25 degrees centigrade, that means when all the reactants are at 25 and when all the products formed are at 25, what is the change in enthalpy of products and reactants? And pressure is 1 atmosphere. So that change is represented by standard heat of reaction, that is delta H, because temperature is 25. Sometimes we refer it as delta H 25 or delta HR not. Okay, so that is the difference between simple heat of, because this is specially for calculation data purpose. Data is available for many reactions. Which data? Standard heat of reaction data is available. But suppose formation of water, standard heat of reaction data is available. But in chemical industry, reactions will not take place only at 25, isn't it? At some temperature, at some pressure, the reactions will take place. Then how to calculate the change in enthalpy? That is our study now in this unit. Ultimately, at the end of this unit, we will do such problems. That is, when reactions actually are taking place at some other temperature other than 25 degrees centigrade, other than 25 degrees centigrade, that means reactants may be at some other temperature, products may be at some other temperature. Then how to calculate the change in enthalpy? That, so before studying that, before doing those problems, first we are understanding the terms standard heat of reaction. That is when temperature is 25, because data is available. Actually, all these terms you have studied in lower classes. Heat of formation, heat of combustion, standard heat of formation, standard heat of combustion, and standard heat of reaction, Hazel of constant heat summation. All these terms you have studied in lower classes. Here we are revising once, and then we will go to the actual problem. So here we have seen what is the heat of reaction and standard heat of reaction. Okay. Heat of reaction is what? Change in enthalpy of the products and reactants. And standard heat of reaction is when temperature is specially 25 degrees centigrade and 1 atmosphere. That is heat of reaction. Why to know this heat of reaction? What is the application? What is the application of use of application of delta HR? Why we need this delta HR? We need delta HR because then only we will know what quantity of heat energy is evolving or will be absorbed. So while designing the equipment, it is very much helpful in the selection of the material, materials, and also what should be the heat removal procedure, how to remove heat transfer equipments, what to use, heat transfer process, heat transfer operations, how to carry out heat transfer operations, all these things, easy to using some coil, how to remove that heat energy that is evolved during a exothermic reaction, how to remove that. If you don't remove that much quantity of heat energy that is evolved in the exothermic reaction, then what happens? Rate of reaction inside the reactor will vary, because rate of the reaction depends upon the temperature. So whenever quantity of heat energy is evolved, then it is to be removed perfectly. Okay, so then how to design of the equipments, design of equipment, design of equipments for a reaction. for reaction process. For reaction process. That is why delta H information is, we should know what is the amount of energy that is involving. And also here then how to know this delta HR values. Delta HR values. Okay, actually it is not practical to measure delta HR values for every reaction, isn't it? But it can be estimated. It can be, wherever it is possible, it can be measured. And wherever it is possible, it can be estimated. Usually it is estimated from delta HF naught, and we will see what are this delta HF naught and delta HC naught. That is standard heat of formation. Standard heat of formation. This data is available in literature, and delta HC naught is standard heat of combustion. Standard heat of combustion. So using this data, we can calculate, or we can estimate, or we can calculate this delta HR values, that is heat of reaction values. So heat of reaction we will understand using an example. For example, consider this reaction H2 gaseous form plus half O2 delta HR equal to minus 286 kilojoules. Okay, let it be equation 1. Okay, now what do we understand from this reaction? Here, 1 mole of gaseous hydrogen and half mole of gaseous oxygen are combining to form 1 mole of liquid water. Okay, are combining to form, here what do we understand from stoichiometry? 1 mole of hydrogen is reacting with half mole of oxygen to form, both are in gaseous form, to form 1 mole of liquid water. This reaction takes place with evolution of 286 kilojoules. So in order to happen this, then 286 kilojoules of heat will be released during this reaction. Okay, 286 kilojoules will be released during this reaction. That is the meaning of this heat of reaction, or enthalpy change, nothing but RQ only it is actually. It is also known as Q only. Okay, so this is my, and whenever we are writing this stoichiometric equation, it is necessary to specify here. It is necessary to specify the state of the components. Which state? Physical state. Okay, physical state of the components, that is both reactants and products. Reactants and products. Why? That means physical state means is it gas or liquid or solid? That state here, hydrogen gaseous form, oxygen gaseous form, water liquid form. Why is it so necessary? Because the enthalpy changes depends on physical state of the reactants and products. Okay, so enthalpy changes depends on the physical state. That is why here we need to mention. For example, we will see, so suppose same reaction, but if the product that is forming is gaseous, then what will be the value of delta HR? That we will see. That is H2 plus half O2 gaseous form gives H2O gaseous form. Okay, here it is a liquid form, here gaseous form. Then what is delta HR is equal to minus of 242 kilojoules. 242 kilojoules. Okay. So I think you got the difference between this and this. The reaction is same, but physical state here is gaseous form, here it is liquid. So delta H value, if it is gaseous form, only 242 kilojoules are required. Liquid state more it is required. That is why whenever you are writing stoichiometric equation, when we are representing heat of reaction values, it is necessary to mention the state of, in the brackets, state of the reactants and products. Okay. And one more point in this we will see. In this class, we are first discussing what is heat of reaction, because this is the main term we are going to calculate in next classes. That is why we are discussing what is heat of reaction in detail. And one more point is here, if for example you take this reaction, suppose you are multiplying the entire reaction with the same coefficient, that means 2H2G plus O2G gives 2 water. Okay, same reaction, same state also, then you are changing the balance here. So you are multiplying the entire equation with 2. So 2H2O it is coming. So when we are multiplying with the same stoichiometric coefficient, we need to multiply delta HR also with the same coefficient. That is the point important. That means in this case, what is delta HR? In this case 286. So 2 into minus 286, that is 572, minus 572 kilojoules. Okay. So using this type of things, next classes we will calculate Hess law of constant heat summation. That is the law of thermochemistry. We use that law to find out heat of formation of some components. So this is the point. Whenever you want to change the stoichiometry, you need to multiply the delta HR value with the same coefficient. Okay. So next class we will study, we will discuss about standard heat of formation and standard heat of combustion. Those two terms we will discuss in the next class. So this class we understood clearly what is mean by heat of reaction and standard heat of reaction. Again, what is heat of reaction? The change, simple words I am saying, the change in enthalpy of the products and reactants. When a reaction is taking place, some quantity of heat energy will be absorbed or some quantity of heat energy will be evolved. What is that amount? That only is the change in enthalpy, change in the heat content of products and reactants. That is called heat of reaction. And when this reaction is taking place at 25 degrees centigrade and 1 atmosphere, then that change in enthalpy is called standard heat of reaction. So what is the difference between these two? It is all standard heat of reaction. Data is available for many reactions in literature. But heat of reaction, because normally in chemical industries, reactions will occur at different temperatures. No? So how to calculate at those different temperatures? That we are going to solve that type of problems. At the end of this unit, we will be learning that topic. Thank you.